Welcome to my channel. Your tutor, Mariam, is here. It's the first video of Introductory Physics 1. In this video, I'm going to talk about measurement, which is the first chapter of Introductory Physics 1. I'm going to talk about basic concept of measurement, and in the next couple of videos, I'm going to solve problems, which I'm going to call it as a simple and challenging ones. So I'm really hoping by watching all this video, you have a better understanding of this subject, and it's helped you to get a better grades in your exam. So if you like my videos, you know what to do. Please subscribe and let's get started. So the first thing is fundamental quantities. The best way to express the physics law is using the math, right? So there are three fundamental quantities that we use. The first one is length. Length is a distance between 2 points, right? And there are different tools to measure the length. The simplest one is ruler. So if I know length, I can measure volume, area. Based on the volume, I can measure the density, right? That's why it is called as a fundamental quantities. The next one is mass. So what I would like to mention here is the way we define mass in physics, or at least here. So imagine I have a paper. I'm going to tear it up to the small pieces, right? I'm not changing the mass at all. So if I keep continue and make it smaller and smaller, the smallest things I can think of is atom, nucleus, quarks, right? I'm still not changing the mass, right? I'm just thinking about the getting to the small point I can get, correct? Now, if I take some pieces out, am I changing the mass? Of course, right? So there are different definition you might find, like a mass number, atomic numbers. The things we define it here is amount of the matter in the particle, which can be simply measured with a scale. Okay, so don't get yourself confused with the mass numbers, atomic numbers. We're not talking about that. We're talking about the amount of the matter in the particle, right? So the last one is time, which can be expressed as t. You can find it as a little t or big T. So yeah. So far we know the fundamental quantities, which is the length, mass, and time, right? So what matters here is units. You might find lots of problems that ask you to convert the units, and you have to be careful about that, okay? But before I talk about the unit, let's talk about the history behind this. So what scientists did, they measure the distance between North Pole and equator divided by 10 million times, and then they define it as a standard length, which is the 1 meter, right? So for a time, 1 second is equal to 9 billion oscillation of cesium atoms. That's a huge number, but it's only 1 second of this oscillation. And for the mass, the story is a little bit different. Before 2018, there was a piece of the platinum iridium in a lab, and they took a measurement of the mass of this punk, and they said that's going to be a standard mass. But after 2018, they come up with a Planck constant and the speed of light, which is all those numbers going to be constant, and they ended up define the standard unit for mass. I'm not going to talk about that equation right now because kind of we haven't go through that equation yet, but in future I'm going to explain it more. But yeah, this is the way how they define the standard units. So we have different units. We have the standard units, as I just mentioned, which is called as a standard international system of units, SI unit, and also we have a non-standard unit, right? So you might find yourself to convert these units. Like you have to convert meters to mile, mile to meters, kilograms to pound, ounces, because different country use different units, and you have to convert them. And as I said, you find so many problems that you have to convert them, otherwise your answer is going to be totally wrong, right? In the next videos, I'm going to solve this problem, go through the examples, show what's the tricks.